in Heaviside function, based on the Heaviside function, we will use it and to find the inverse of the Laplace transform. So let's proceed our discussion. Don't skip a second for a video, so you miss the concept that I are hiding in the this video. So if you are new on my channel, so don't let you go without subscribing my channel. So and let you go without follow my page, Facebook page. So let's proceed our discussion. Link in on like, share, subscribe, and share with your friends so that you have it. So Heaviside function or Heaviside theorem. Heaviside function. Heaviside function or Heaviside theorem. So let's say f of s by gs is our function. So where power of f of s is less than equal to power of gs. So then there exists a function such that inverse of f of s upon gs equal to f of ar upon g dash ar into ar t. Obviously gs can be factorized as s minus alpha 1, s minus alpha 2, dot s minus alpha. Okay, let's prove our result and prove where that gs equal to s minus alpha 1, s minus alpha 2, dot s minus alpha r. So we can write it inverse of f of s upon g dash s equal to a upon s minus alpha 1, a1, a2 upon s a2 minus ar upon s minus ar. So which can be written as summation ar upon s minus ar r 0 to infinity. Obviously, now the question arises, what is ar? Okay, how to find ar? To find ar, that is the partial fraction. We have already seen it, partial fraction. To find the ar, okay, we put that s minus ar equal to 0 as 10 to ar part. Okay, so ar will give us multiplying both sides or multiplying with s minus r. So f of s minus r g dash s limit s equals to ar. When we put ar, that will give us 0 by 0. So by using Ahmed's theorem, okay, we get f of ar upon g dash s ar, g dash ar. So f of s equal to g dash ar. So that is our ar. So since this is our ar, okay, this is our ar. So by Laplace transform. So Laplace transform we get f of s upon gs equal to qs. Let's say qs eat, that is our function. We have summarized it as ar, that is ar t 0 t ar. So that is our so f of s equal to this. So which give us f of ar upon g dash ar into e dash ar t by using the Laplace transform. Inverse of f of s we get it by inverse of the Laplace transform. Okay, by taking the Laplace transform on both sides. So ds upon we get, this is our proof. I think you have got it. So moving to the next theorem. If you have read it, I am going to solve the question based on this. So let's proceed. So if let's say f of s question, f of s upon g dash s is given by 2s plus 3s plus 2, okay, and s cubed s minus 1 and s plus 2. Now find the Laplace transform of this, which is give us f of s upon s cubed, which is the form gs. So f of s will give us 2s cubed plus 3s plus 2. gs equal to s cubed minus s minus 1 s plus 2. So to find the value of ar, we put s equal that is equal to 0 so that we can find it. Okay, let's say s. So when we put it equal to 0, s equal to 1, s equal to minus 2. Now gs equal to s cube. Okay, minus 2s square plus 2s minus 2s. Okay, that is our result. So g dash s will give us 3s square minus 2s and 2. So g0 will give, so which give us a1 upon s plus b a2 upon s minus 2 plus a3 upon s plus 2, which is equal to this nothing but f of 0 upon g dash 0 into e into 0 t. Okay, plus f of 1 upon g dash 1 into e into t plus I am raising it e 2t f of 2t by g dash 2. So that is the value we get. That give us 1. So when we put f of 0 give us 2 and g dash 0 is give us minus 2 into 1. Okay, plus f of 1 will give us 2, 3, 5, 7. 7 by g dash 1 will give us the value of g dash 1 will give us 3 minus 1 e t plus f of 2 will give us 8, 16, 6 plus 2. That give us 12, 22 upon, that will give us 12, 4, 6, that is 6 e 2, which give us 3, 11. So minus 1, 7 e t plus 11 e 2t, which is our inverse of this Laplace transform. So write down it. I am back. Have you write down it? Okay. I am going to the next. So the next part. Find the inverse of a Laplace transform. By using Heaviside theorem. So if we have f of s, let's suppose 2s plus 3, s plus 1, s plus 2. We have to find the inverse of this. How to find it? So let will give us s minus 1 plus, okay, a to s minus 2. So we have written it. So let's erase it. Okay. So here put gs equal to 0. So s equal to 1, 2. Now gs equal to what? It is sk minus 3s plus 2. Okay. Yeah. So that give us g dash s give us 3s 2s minus 3. So g1 will give us 2 minus 3, that is 1. g2 give us 4 minus 3, 1. So that is the integration f of 1 upon g dash 1 into et plus f of 2 upon g dash 2 into et. So find out whether that is your result. Okay, how you get it right. So which give us f of 1 what? Minus 1 minus et plus f of 2, yeah, f of 1 is I think 5, okay, that is 5. F of 2 is what we have written, see, the value of f of 2 is 4 plus 3, that is 7. So the value will give us 7 by e 2t, which is our Laplace transform. Okay, I am reading it. Find the inverse of Laplace transform. S cube s square 2s plus 3 upon s cube. Okay. S square plus 2 s minus 2. Can you find it? So let's say s gs equal to s into s square plus 2 and s minus 2. So g dash s equal to 0. So s equal to 0. S square minus 2 equal to 0. S equal to plus minus root 2 I. Okay. Minus root 2 I and s equal to 2. So now above 0 is give us 3, f of 2 give us 4, 6, 4, 4, 8, 11, and f of I root 2 give us 2, 2 root 2 plus 3, that is our 5, okay, and f of minus I root 2 give us minus plus, okay, here minus, that will be plus minus, okay, that is give us minus 1 plus 2 root 2 pi. Okay, so the Laplace transform according to the f of 0 upon g dash 0 f of 0 into g dash 0, okay, e into 0 plus f of here what, plus root 2i f of root 2i upon g dash root 2i into root 2i t plus f of 0 minus I root 2 upon g dash minus I root 2 into e minus 2 root 2i t plus f of 2 upon g dash 2 into e 2t. Put the value, get your answer. I think you have got it, that how to find the inverse of the Laplace transform. So we'll meet another interesting video. Do like, share, subscribe for that. Thank you.